All right, guys. So what we're doing first and looking at first is summation notation, series and summation notation. Now, we call a series a group of numbers that are all going to be added together. So it's almost like a sequence, but instead of just listing the numbers out, we add them all together. So here we would do 2 plus 4 plus 6 plus 8, which incidentally would be 20 if we added them all together. Infinite series says we continue on just forever. We keep going along in the sequence and adding those numbers together. And if we did end up adding all the numbers together, this is going to go towards infinity, because if we keep going on and adding that together, it's just going to keep getting bigger and bigger and bigger. We don't actually get a number. And when we have an infinite series like this, where we keep adding bigger numbers to it, we call it divergent. It diverges towards, here it's going to diverge towards infinity, or negative infinity. Now that's not going to be true for all series, all infinite series. Some infinite series are what we call convergent. It's going to converge to a number or a point. Now, we can write these finite and infinite series in what we call summation notation, or sigma notation. We write it in this form, where the I equals or n equals is the number we start with, and the number on top is the number or the sequence that we end with. So with a finite, we'll have a number on top. In an infinite sequence, we'll have infinity on top, so it just continues on forever. We're on the next page. So if we look at this first one here, the first thing we need is the rule. We need to make a rule for this here. Well, we notice that the first term is 25, second one's 50, third one's 75. So for each term, we're increasing by 25. So our rule is actually 25n. Because if n is 1, 25 times 1 is 25. Our second term, when n is 2, 25 times 2 is 50. And with 3, 25 times 3 is 75. But we need to figure out which term 250 would be, because we do have a definite end. And this would be what? What term would 250 be for this sequence? 10. So that tells us we have the first through the 10th term. So to write our summation, we'll start off with this here, and we'll say n equals 1, because we're starting off with the first term, and we're going to what term? The 10th. And we put our rule next to it, 25n. And that's how we would write a summation notation for a finite series. Questions on this here? Now for an infinite series, I'm just going to tell you that the series for this, the rule is going to be n over n plus 1. Now we start off writing the summation pretty much the same as before. So we have our sigma. And again, we're starting off with n is equal to 1. But this time, what is our last term? We don't have one, so it's going to be infinity. And next to it, we have our rule. It's just finding it. Because here, the number's on top. So this is our first term, second, third, fourth. Well, the numerator matches the term. And then the denominator is one more than which term we were at, so we have n plus 1. So again, some of the rules like we did on Monday are easier or harder to see. This one, once we're kind of looking at the term and the numbers, it is a little bit easier to see. The next thing we're going to look at is actually finding the series. So we're going to jump ahead again. I think you're missing a page. Okay, because you'll need it again. Now, finding the sum, what we're going to do is replace each value of k into the series. Now, the first value of k that we're using is 4, because it said k is equal to 4 to 8. So we're starting at 4, going all the way up to 8. So we'll start off with 3 plus 4 squared. Then we're going to add to it 3 plus 5 squared. And we'll add to that 3 plus 6 squared. Then we'll add to that 3 plus 7 squared. Then we'll have plus 3 plus 8 squared. So we're just adding each one of these values in the series. And when we simplify these, we'll have 3 plus 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. And 8 squared is 64. Now we can add each one of these together. 16 plus 3 is 19. 25 plus 3 is 28. 3 plus 36 is 39. 3 plus 49 is 52. And 3 plus 64 is 67. And lastly, we can just add these together. 19 and 28 is 47. 39 plus 52 is 91. 91 plus 47 is 138. And 138 plus 67 is 205. And that's it. It's also telling us that the fourth term is 19, the fifth term is 28, sixth term is 39, seventh term is 52, and eighth term is 67, because those are each of the terms of the series. And we're just adding all those together. Questions on any of these here? So looking at the series, where are we starting? Because the bottom number gives us our start, the top number gives us our end. So we're going to start with 4 and go to 8. So on the next one here, we're starting at 3 and going to, so we'll have 4 times 3 minus 1 plus 4 times 4 minus 1 plus 4 times 5 minus 1 plus 4 times 6 minus 1 plus 4 times 7 minus 1 plus 4 times 8 minus 1 plus 4 times 9 minus 1. So we have 7 terms. Now at this point, we could plug this all into the calculator and let it do it for us. Or if we work this out here, 4 times 3 is 12 minus 1. 4 times 4 is 16. We have 16 minus 1. 4 times 5 is 20 minus 1. 6 times 4 is 24. And we have our minus 1. 7 times 4 is our 28. 4 times 8 is 32. And 4 times 9 is 36. Then if we simplify this here, we'd get 11 plus 15 plus 19 plus 23 plus 27 plus 31 plus 35. I need to give you all a second to write. Actually, Mariah, if you hold on a second, I'll show you an even nicer way to do it. We good? Now, what I'm going to do next, I think you've seen probably on social media somewhere, adding by base 10, like what, adding two numbers, what can we do by base 10 to get there? Or nicer numbers to add. Now, normally I would go exactly 11, 15, 19, 23, 27, 31, 35 at the end. What if I add 23 and 27 first? What is that? 7 and 3 is 10, right? Carry the 1 gives us 50, yes? How about 19 and 31? Is 50, isn't it? And the reason I'm picking those as well, 19 and 31, the 9 and 1 could give us a 10, yes? Which would make 20 and 30, which give us 50. They work out nice. 15 and 35, 5 and 5 gives us a 10, which actually incidentally gives us another. Does that make sense?
Not really, but
essentially, I'm just trying to find ways to give us a nice 0. Because here are the 5 and 5 would give us 10. So
I get what you mean.
yeah, it's yeah, not the way you'd see it. And again, I would have done, if I wasn't looking for that or seeing kind of, I'd step back and say, is there maybe a possible way to get nice numbers? I would have gone with 11, 15, 19, 23 and just paired them up like you were going to do. And we should get to 161 no matter how we add them. Because especially if I'm trying to add these in my head, I always try to see which ones combine nicest and go from there. Because we could have also done 19 and 11. They add together nicely. Questions on any of this here? Now there are certain formulas that are what we call special series. The first one, the sum from 1 to n of 1 is just n. So if we add 1 to itself n number of times, we'll just get however many times we added it together. Now the second one is actually quite interesting, the sum of the first n positive integers, which means like if we went from 1 to 100, adding the numbers all the way from 1 to 100, we can use this formula here. So n is 100, so we have 100 times 100 plus 1 over 2, which would be 100 times 101 all over 2. Now we can multiply 100 and 101 first, or we can divide 100 by 2, because what's 100 divided by 2? Times the 101 is 5,050. So instead of adding 1 and 2 and 3 and all the way up, we could use this here. Does that kind of make sense? Now the formula actually is quite clever, because if we take 1 to 100, I'm going to fold it in half so that 1 and 100 are right next to each other. So what is 1 plus 100? Well, the next number after 1 is 2, and the number it would match up with is, well, what's 2 plus 99? Then we'd have 3 and 98, which is so 101. And we could continue like this all the way down to 50 plus 51, which is 101. Now, how many times would we have this? Because we folded the numbers in. Yeah. So we're looking at 50 times 101, which is our 5,050. And that's really about, or essentially a roundabout way of how they actually got to the formula, supposedly. Kind of an interesting thing. Now, the one after it, the sum of squares, essentially if we took this but squared each number. So looking at, say, 1 squared plus 100 squared, 1 squared plus 2 squared plus 3 squared, going on would be this formula here. Okay, questions on any of this here? So, I equals 1 to 5. See here, let's clear all that out. Now, we could type this in the graphing calculator. Hit math, go up 1. There's something nice there. What's 0? Summation. So I can say x equals 1 to 5, and we had 8x, because whatever variable you put underneath is what you have to match up inside. I think the first one we had was, what was it? 4 to 8 of 3 plus x squared. I think is the first one we did. Back a page or two. Huh? Yeah, so math, 0. We can do 0 to 8. And we can put whatever we want. Some that behave a little weirdly. Let's say -1. Instead of 2 the power, let's put x. This might break it, but yeah, it's going to be funny if it comes up as 0. Takes it all this time to say 0. It might be a while. So we'll come back to it in a second. But your homework is, none of the rest of it is just 39 through 46. Yeah. (39 through 46), we're going to let it think and see what it finally comes up with. So one of the things we know so far about it thinking this way is that it doesn't have an overflow error. The number's not got massively big, but it is still working on it. Math, and then go down, or up, or 0. This is quite impressive, but it's still thinking. I'm just going to let the video keep running until it finally figures out an answer. Yes. Well, y'all have seen the calculator really think. It's still going. I'm curious how long it's going to take it to figure this out. Let me look it up. Yes. Come in. I'll pause it and see. It's still working. It should eventually tell us that the answer is 0. Well, all we're doing is taking -1 to a power, and even powers are going to be +1, and odd powers are going to be -1. So essentially what it's doing here, so -1 to the 0 would be 1. -1 to the first would be -1. So we have 1 plus -1 plus 1 plus -1 going back and forth. And pretty much all of them, except for the last one, or actually all of them, are going to pair up with 1 and -1. And 1 plus -1 is 0. So it should all cancel out and be 0. Yeah, it's going to make a thing for a while. Thank you. Well, so the answer is 0, but who knows how long this is going to take. I'm going to stop recording it.